Tonight we'll be looking at 1.2, which is on solving linear equations. Now, if you remember from last year in Algebra 1 in your classes, linear equations are equations that have a power of 1 in the variable, okay, or it makes a line on its graph. And when we're solving linear equations, we're going to isolate the variable given, so x, m, you name it, to solve for a solution. So a couple of key vocab terms we need to remind ourselves of are variable. Okay, what is a variable? A variable represents an unknown quantity, or it's a quantity that varies. Okay. An equation is a mathematical statement with two expressions set equal to each other. So equation has an equal sign usually. And then a solution of an equation is a value for the variable that makes the equation a true statement. So solution would basically be the answer that we're looking for when we solve equations. So let's go ahead and look at some examples. Number 18 says 7m minus 4 minus 9m minus 36 equals 0. And we want to solve this linear equation. We want to solve for the variable given. In this case, it's m. So first thing I'm going to do is I'm going to see which ones are the common terms. So I notice that 7m and negative 9m look similar. And then I see that at negative 4 and negative 36 are common like terms. So I'm going to combine those. So 7m minus 9m is negative 2m. And negative 4 minus 36 is minus 40. And then I copy my equals 0. From here, I want to isolate my variable as much as possible. So I want to get eventually m by itself. In order to do that, I've got to get the negative 2m here alone. So I'm going to add 40 to each side. I'm left with negative 2m equals 40. And then again, the whole point is to isolate m. To get this isolated variable, I'm going to divide both sides by the constant attached to the m. So in this case, negative 2. So now I get m equals negative 20. And that's my solution. For 22, it says 92 equals negative 4 times quantity 2r minus 5. So what we're going to do first is we're going to work with that negative 4. So I'm going to distribute it to the 2r and then to the 5 as well. Make sure you bring that negative as well. So it's going to be 92 equals negative 4 times 2r minus a negative 4 times 5. From here, I'm going to simplify. So now I get 92 equals negative 8r plus 20. And then I want to get the negative 8r by itself, so I'm going to subtract 20 from each side. And I get 72 is equal to negative 8r. To solve for r, I'm going to divide both sides by negative 8. So r will be equal to negative 9. The last problem we're going to look at on this section right now is 26, which says 1/2 x plus 2 equals 1. We're still solving the linear equation, so we're still going to solve for the variable given. In this case, the variable is x. So first thing I'm going to do again is get that 1/2 x by itself. So I'm going to subtract 2 from each side. So now I get 1/2 x equals negative 1. And then I need to get the x alone, so I'm going to multiply both sides by the reciprocal of 1/2. So x will be equal to negative 2. Now we're going to look at 30, which says 3m over 4 minus m over 12 is equal to 7/8. And so to solve this, we need to get a common denominator, or an LCD, throughout the whole problem. So if I look at 4, 12, and 8, I notice they have a common multiple of 24. So what I'm going to do is I'm going to multiply the whole problem by 24. So I'm going to take the 24, distribute it to the 3m over 4, to the m over 12, and to the 7/8. So I end up with 3m times 24 over 4 minus m times 24 over 12 equals 7 times 24 over 8. From here, before I start combining like terms, I'm going to simplify everything I can. So I notice that the 4 goes into 24 6 times in the first term, so I end up with 3m times 6. And then in the second term, I notice that 12 goes into 24 2 times, so I end up with m times 2. And then in the last one, I notice that 8 goes into 24 3 times, so I end up with 7 times 3. Now I'm going to simplify each expression. So I've got 18m minus 2m equals 21. I'm going to combine any like terms I see, so I notice that I've got 18m and 2m, which are like terms. So that becomes 16m equals 21. And then to solve for m, I'm going to divide both sides by 16. So m equals 21 over 16. Or, in proper format, it's 1 and 5/16 with the mixed fraction. Now we're going to look at a final equation where this time instead of fractions or whole numbers, we end up with decimals. So the way I'm going to treat it is exactly the same though, even though I have decimals. I'm going to start off by trying to isolate my variable as much as possible. So I'm going to add 1 to both sides. So I end up with 0.1r equals 1.65. From here, to solve for r, I'm going to divide both sides by 0.1. So r equals about 16.5. So now that we've talked about solving equations, let's look at solving word problems. Okay, so we're going to use our knowledge of equations that we've been looking at this entire section, and we're going to start using that to create an equation based on a word problem. So here it says the sum of 3 consecutive integers is 132. What are the 3 integers? So remember, consecutive just means that it goes in order. So it's numbers like 3, 4, 5. Those are consecutive integers because they go in order. So what we're going to do is we're going to create a variable. So let's start off with x. And let's say x is our first integer. Okay, so x can be any number, we don't know yet, but we're going to figure it out. Then the second integer is only one more than x. So x plus 1 must be the second integer. And then if the second integer is x plus 1, then the third integer must only be 2 more than x, because that's to be consecutive. So then that's x plus 2 must be the third integer. Okay? So from here, now that I've kind of labeled every single part of my problem, I'm going to then look at this sentence they gave me at the very beginning. It says the sum of 3 consecutive integers is 132. So I know sum tells me I'm going to be adding up 3 numbers that are consecutive, and then those 3 numbers added together must be equal to 132. So the is tells me I have an equal sign, and the sum tells me I'm working with plus signs. So now I'm going to take my variables. I'm going to take my first integer, which is x, add that to my second integer, which is x plus 1, and add that to my third integer, which is x plus 2. And then I know that must be equal to 132. So now that I've written an equation describing my problem, I'm going to simplify. So I notice I've got 3 x's in common, right? And I've got a 1 and a 2 in common on the left-hand side. So I'm going to combine those. So I end up with 3x plus 3 equals 132. And then to solve for my solution, I'm going to subtract 3 from both sides. I get 3x equals 129. And then I'm going to divide both sides by 3 to isolate that x. So what I end up with is x equals 43. So this means my first integer must be 43, because we said at the beginning here that x must be the first integer. So then to find the remaining two numbers, what I'm going to do is I'm going to add 1. So x plus 1 must be 43 plus 1 must be 44. So that's my second integer. And then to get the last one, we said that was x plus 2. So we're going to do 43 plus 2. So that must be 45. And that has to be my third integer. And notice these integers go in a row, 43, 44, 45. So the three numbers are 43, 44, and 45. So let's look at a different type of word problem. This time the problem says, Latanya will walk her bike from her house to the bike shop at a rate of 3 miles per hour. The bike shop is 1.5 miles from her house. She expects to wait 30 minutes for the bike to be fixed. Then she will ride her bike home at a rate of 10 miles per hour. Can she be home in 1 hour? So what's going to help us is that we're going to draw a quick table of the information we've been given in this problem. So we have 3 stops, right? Or 3 instances of time. We have her walk from the house to the bike shop. We have her time waiting at the bike shop. And then we also have her time riding back. Okay? And to solve an equation like this one, this is a problem that's requesting us to use a distance equation, because we're looking at distance and time it takes for that distance. So that equation is known as d equals r times t, or distance equals rate times the time it takes to complete that. Okay, and what we're going to do is we're going to solve this for the time it's going to take. But first, let's write down what we have. So we don't know what the distance is. We do know what the distance is, right? We know that the walk from her house to the bike shop is 1.5 miles. We also know that the ride from her house to the bike shop is also 1.5 miles. And then we know that the distance she travels while she's waiting is not going to be any distance, because they just told us that's how long she's waiting. Okay? And then the rate at which she travels is given to us as well. They tell us that she's going to be walking at a rate of 3 miles per hour when she's walking. And then they say that she's going to be riding at a rate of 10 miles per hour. And again, because we're not moving in the moment that we're waiting, that one also remains blank. So then the time it takes is unknown to us. We don't know how long it's going to take her to walk to the bike shop. We don't know how long it's going to take her to ride from the bike shop. But we do know that she waited 30 minutes at the bike shop. So now what we're going to do is we're first going to convert 30 minutes into an hour, because our rates are all in hours, if you notice. So we're going to convert this into an hour, and 30 minutes is 1/2 of an hour, because there are 60 minutes in an hour. From here, we're going to set up an equation to solve for time, because that's what we're looking for, really. We want to know her time. So in order to solve for time, going back to this dirt equation over here, I'm going to divide both sides by rate. So originally I had d equals r times t. And now I'm going to divide both sides by r. So I get d over r equals t. And that's how I'm going to set up my total time equation. I'm going to have a setup for how long it's going to take her to walk, how long it's going to take her to ride, and how long it took her at waiting. So it's going to be 1.5 over 3 for the walking, plus 1/2 for the waiting, plus 1.5 over 10 for the riding. And that must be the total time it takes her to go from her house to the bike shop, get her bike fixed, and then come back from the bike shop to her house. So now what I need to do is I need to get a common denominator on the left-hand side of the equal sign. So I notice that the common denominator here is 30, okay? So I'm going to multiply the first fraction by 10 over 10 to get that common denominator. We'll multiply the second fraction by 15 over 15 to get 30. And then I'm going to multiply the last fraction by 3 to get 30. And that must be equal to t. Now that I have that, I'm going to simplify. So this becomes 15 over 30 plus 15 over 30 plus 4.5 over 30 must be equal to t. Now that my denominators are all the same, I can combine the numerators. So I get 15 plus 15 plus 4.5 over 30 equals t. So t ends up being 34.5 over 30 equals t, which when I divide that, I get 1.15 hours. Okay, and 1.15 hours is more than 1 hour. So, no, LaTanya will not make it back in an hour. Let's do one more problem with LaTanya, okay? So we can keep working on this rate, distance, and time kind of question. So this time it says, LaTanya leaves her house at 12:30 p.m. and bikes at 12 miles per hour to Marta's house. She stays at Marta's house for 90 minutes. Both girls walk back to LaTanya's house along the same route at 2.5 miles per hour. They arrive at LaTanya's house at 3:30 p.m. How far is Marta's house from LaTanya's house? So the way we're going to set up the equation for this problem is the same as the last example. We're going to use the distance equals rate times time equation. But we're going to solve it for t because we're given a lot of stuff in terms of time, so it's just easier. So I'm going to divide everything by r, and I get t equals d over r. So again, what's going to help me is drawing a nice table for myself. So I know that when she is going from her house to Marta's, so Elle's house to Marta's house, she's going to be going at a rate of 12 miles per hour. I also know that when they're going from Marta's house to LaTanya's house, they're going to be walking at a rate of 2.5 miles per hour. So then the total distance, or the total time for the trip, can be given to us. And the reason why it can be given to us is because they tell us that she starts traveling at 12:30 and that they're done traveling at 3:30. So if I do 3:30 minus 12:30, I see that they've traveled 3 hours. Okay, so their total time is 3. I don't know what their rate is over the whole thing, and I don't know what the total distance is, but I do know that the distance from Latania's house to Marta's house and Marta's house to Latania's house is the same. So I'm going to say that x is the distance from Latania's house to Marta's house. And it's the same for both. So I can write the time equation as its distance divided by rate, right? As we see over here on the right-hand side of the screen. So this will be x over 12 from Latania's to Marta's, and then x over 2.5 from Marta's to Latania's. So when I write my total time equation that we used last time, first we're going to look at when she's going from her house to Marta's house, so that's x over 12. We're going to add in 90 minutes because that's how long she waited. But I don't want to do 90 minutes because everything's in hours, so I'm going to convert 90 minutes to hours. And that's going to be 1.5 hours. So 1.5 plus, and then I'm going to add in my new time equation from Marta's to Latania's. So that's going to be x over 2.5. I know that since she started at 12:30 and they got back to Latania's house at 3:30, it took 3 hours. So total time is actually 3. So if you notice, I only have one variable again. That is x. And that's what I'm going to solve for. So the first thing I'm going to do is I'm going to get a common denominator on the right-hand side. So we know that 3 is equal to 12 times 2.5, which is 30. Okay, so it's going to be x over 12 times 2.5 over 2.5 plus. And then I'm going to do 1.5 times 30 over 30. And then I'm going to then do x over 2.5 times 12 over 12. And now I simplify. So I end up with 2.5x over 30 plus. This ends up being 45 over 30 plus 12x over 30. And then I'm going to simplify again by combining like terms. This ends up being 2.5x plus 45 plus 12x over 30. And I want to get rid of this denominator, so I'm going to multiply both sides by 30 to cancel out the 30 in the denominator here on the right. So then I end up with 90 equals 2.5x plus 45 plus 12x. Now I'm going to combine like terms, which are 2.5x and 12x. So 90 equals 14.5x plus 45. And then subtract 45 from both sides. I get 45 equals 14.5x. And so then I'm going to divide both sides by 14.5. And I get that x must be about 3.1 miles. Because remember, x represents the distance between Latania's house and Marta's house. And so my answer is 3.1 miles. And that is the lesson for 1.2. So we'll have time to go over this again tomorrow in class, but the classwork that will be due at the end of the period will be on page 16, numbers 11 through 37, odd, 38, and 40. And I'll see you guys tomorrow.